In this video, I'm going to go over the answers to quiz number 5 for Honors Calculus for the fall 2017 semester. So number 1 says, draw a function with exactly 2 inflection points. Now, inflection points are when the function changes concavity. So I could do this, and then right here, it's a point of inflection. So that's 1, but I need a second one. And so a second one would look like that. So we have to have concave down, then concave up, then concave down. But you have to have exactly 2 inflection points. Number 2, draw a graph where the first derivative is always positive and the second derivative is always negative. And so that means if the first derivative is positive, then that means this function is always increasing. But if the second derivative is always negative, that means it's concave down. So that means it has to look kind of like that. For number 3, a lot of people really dodged this question. They read it and then interpreted my question as being something totally different. And so when the derivative equals 0, why does an extrema not necessarily occur there? A lot of people took it as, well, it could also be, an extrema could also be where f prime is undefined. That's true, but we're focusing on where the derivative equals 0. Why is that not necessarily an extrema? Because for it to be an extrema, it has to change sign. That's what it has to be. That's the answer. For number 4, we want a positive first derivative. That means it has to be increasing. So these values are increasing, these are increasing. These are decreasing, decreasing, decreasing. So we can knock out C, D, and E just by taking a first derivative. A negative second derivative. So that means it has to be concave down. That means it has to be increasing at a lower rate. So here it's plus 2, plus 3, plus 4. Here it's plus 4, plus 3, plus 2. So that would be concave down. So number 4 could potentially be a table of values for the graph for number 2. For number 5, we want to find the values of C and D so that it is both continuous and differentiable. So that means if I plug in 2, these two parts should be equal. So that means 2c plus d equals 4 minus 2c. But if we also plug in the derivative, that's going to be c for here, and then 2x, so that's 2 times 2, which is 4 minus c. So what we can do is we can use this to find the value of c. So 2c equals 4, so c is going to equal 2. And since c equals 2, I can then plug that in over here and get 4 plus d equals 4 minus 4. And so 4 plus d equals 0, so d equals negative 4. So those are the values that will make this continuous and differentiable. Hope this helps. If you have any further questions, type them in the comments below.